Hello, welcome back to another lecture. We're going to talk about shear stress again. Let's look at this example. We have this member here and we want to find out what is the maximum shear. So we're looking for tau max. And the formula for that, as you know, is equal VQ divided by IT. Okay? So when we have a member here, the first thing you want to really do, find the neutral axis, because you need neutral axis to calculate your Q and to calculate your moment inertia. And how we do that is, you remember when you did a bunch of these, y bar is equal to summation of y bar times A divided by summation of all area. Now, when I look at this member, let's measure everything from bottom here. Let's call this X right here. All right, from right there. And we have three, we can break it down to three different shapes. First shape will be right here. This one and 1B. They're both the same thing, same exact thing. They're both 1 inch wide by 2 inch. So if this is 3 inch, this will be 2 inch right here. Okay? And then the third shape will be on top, which will be 5 inch by 1. So the first we're going to go with these two shapes because they're both identical. Why not just put a 2 in front of it and do both of them at the same time. And y bar, what's y bar? Y bar is the center of this shape, first one. And the center of this shape is 1. From here, from the line that we're going to make, it's going to be 1. So that's 1. And the area is going to be 1 by 2. Now we're going to go, so we did this two shape. We did shape 1, shape 2. We're going to go to the third shape, which is on top. The y bar is right here. It's going to be from center of here all the way to here. So we know it's going to be 2 inch here, and this is 1 inch, so it's going to be 2.5. It'd be 2.5, and the area be 1 by 5. So y bar comes out to, I've already calculated that. Oh, we got to divide by the area. I knew I forgot something. All right. The area of the first one is, there's 2 of them again. It'd be 1 times 2. And the area of the second one would be 1 times 5, which is equal. There you go. That's much better. So that comes out to 1.833. So now we have that. That's going to be, let's use a different color here. My neutral axis is going to be 1.83. So let's put a line through here. A little bit higher, actually. That's neutral axis. And put A on this end. And neutral axis is from here, it's going to be 1.833. Great. So let's find out the moment of inertia. I is equal, you know the formula, 112 BH cubed plus AD squared. Okay, let's deal with the first shape again. There's 2 of them, so I'm going to say 2 for both of them, and 112. And my B is 1 inch. My H is 2 by power of 3 plus area, which is 1 times 2, and D. Now D is the center of this shape, the difference between the center of this shape and a neutral axis. The center of the shape is 1, neutral axis is 1.883. So it's 1.833 minus 1 squared. All right, plus, that was for shape 1, plus, and that was for shape 1 and 2, or 1 and 1. And then next shape will be up here, and that will be 112. B is 5, H is 1 cube plus 1, 5, and let's figure D out. So the center of this shape is 2, and if you divide 1 by half, it'd be 2.5, right? 2.5. So it'd be 2.5. We're looking for this right section right here. 2.5 minus 1.883. Okay, 33 squared. All right, I have done this already. That comes out 675 inch by power 4. All right, now we got the moment inertia. Let's go find the Q. When you do the Q calculation, take a look at it, which way is easier for you to do the calculation. The Q max mean if I go anywhere above neutral axis or below neutral axis. So Q top from the Q bottom, they're both equal. But which way is easier for me? If I use the Q top, so I got to calculate this area and plus this little area and plus this little area. But if I do Q bottom, all I have to do is this area, I already know the dimension because I already said this is 1.883 by 1. So that makes it easier. So let's go to the bottom one, and then we have the two thick. And Q is summation y bar time A, area. So in here we have the y bar, it's going to be from the center of my shape to the neutral axis. My whole shape is 1 point right here. My whole shape is basically this area. Right? And therefore, it's 1.883, and the center will be 1.833 divided by 2. That's my y bar, and the area be 1.833 multiplied by 1 inch. And guess what? There's 2 of them, right? So that comes out to I got it right. 3.3611. That's an inch cube, and that's not a volume. Okay, so now we got the Q. We got everything basically. All we have to do is calculate the shear max, and the shear max will be which is Q max here, V Q max divided by I thickness, 18 kips, and Q was 3.3611 divided by I, where are you? 675 multiplied by the thickness. Now what's the thickness here? Yeah, it's 2 times 1 inch. There's 2 of them. Don't forget, so times 2 times 1. And that comes out to 440 KSI equal 4.48 KSI. So that's how you do it. You got to make sure you understand the concept here. First, you got to find the neutral axis, number 1. Number 2, you find the moment of inertia. And then you find Q. When you find Q, you have to be careful. For Q max, either going to be below neutral axis or above neutral axis. And what if it's easier for you? And then divide by I and T. Nothing to it. So I'm going to erase this part and do another problem. Pretty cool. Look at this. 1, 2. Pretty good, huh? Even put a new image on. This is the same problem as like last one, just different shape. This time, instead of looking for the maximum shear, we're going to want to know what is the shear stress exerted by the web at point A and point B here, at those two locations. Let's call this A and B. Again, this is just like the previous example. The shear max is VQ. I mean, that will be, okay, now the shear is equal VQ divided by IT. Again, first thing we want to do is find a neutral axis. And because we have 1, 2, 3 different shapes, so we need to find out what our neutral axis is. And the formula was summation y bar times A divided by the total areas. And look at the first shape, and let's reference everything from bottom here. Okay, first shape, which says B here, the center of it will be what? It will be, because it's a 30, so it will be 15. Be careful, this is a millimeter, we want to convert to a meter. So 15 divided by 1,000, it will be 0.015. Okay, so y bar will be 0.015 multiplied by the area. The area is 125, which is 0.125 multiplied by the length width, it's 30.03. Okay, so divide this by the area below it. The area will be again 0.125 times 0.03 plus. The second shape is right here, this section. The center of this shape is what? Is 250 divided by 2 is 125. So 125, but it's 125 from here. 125 from the X will be 125 plus 30 will be 155. So center of this shape will be 155 to the our reference point. 155 is 0.155 multiplied by the area. The area is 250 by 25. Be careful, this is 25, that's a 30, that's a 30. So time 250, 0.25 times 0.025. All right, the area will be again 0.25 down here, 0.025. Plus, we got one more shape left, and that's on the top. So when we go to the shape on the top here, the center of this shape is right here, and is how far is from here. So if you go from bottom to top, 30, 60, 250 is 310. 310 come back down 15, right? So it'll be 15, it'll be 295. So it will be 295, that will continue, 0.295 times the area is 200 by 30. 0.2 times 0.03. Okay, divided by the area, which is 0.2 times 0.03. Let's see what I got. Oh, the answer is 0.1747, and that's meter. So now we know the neutral axis is somewhere around here. In A, and that's about 0.1747. Okay, now we have that. Again, same thing. Let's find the moment inertia. And moment inertia for both three shapes is equal 112 BHQ plus AD squared, because the shape we have is all rectangular, so this formula will apply. First shape is 112. My B is 125.125. My H is 30, so 0.03. And that's cube plus area, 0.125, 0.03. Now D. D is the difference from center here to the center there. So it'll be 0.174 minus, okay, so I'm going from here to here. 0.15, right? 0.015 squared. And that's the shape 1. Let's do the shape, second shape. And plus 112. B is 0.025 times 250 cube plus the area 0.025 times 0.25 and D squared. And the D squared is the center of this shape, difference between the center of this shape and that. So the center of this shape is 125 or 155 from here. So it's 155 from here, and it will be 0.174 minus 155. 0.1747 minus 0.155. Right, squared. Now let's do the third shape, which is plus. That's a plus here, that's a plus here. 112, and our B is 200.2, our H is 0.03, Q plus 0.2 times 0.03, D. D is, should be same as from here. The difference between here is 295. We figured this was 295 here. So 295 minus 0.174. So it's 0.295 minus 0.1747 squared and equal. That's a lot of. Okay, this comes out to 0.218 times 10 by negative 3 cubic. All right, good. Let me double check that. Got it. All right, so we got that. We found everything. Now we got to find QA and QB. All right, let's make room here so I can go ahead and use the room efficiently. There we go. What's QA? First we're going to find out QA, which is y prime A times A. And what is y prime A? Look at the QA, and that's the difference. Again, it's the same difference we have right here, really. Where'd it go? 0.295. It's the same D. It's just like that. It's that area between the center of this and the neutral axis. So that's my y prime A. And that's, we figured this was all the way 295 to here, and 295, and then up to here is 174. So it will be equal 0.295 minus 0.1747, and that's times the area. And I don't like this marker anymore, it's fired. Gotta get a new marker. Time, it will be 0.03, the area, multiplied by 0.2. And that comes out to 7219. Okay, 10 negative 3. Let's figure out QB. And that's y prime B times the area, which is equal. It's going to be the distance between here and a neutral axis. And that's going to be 0.1747 minus 0.015, because that's the 15, right? And the area, well, it's going to be 0.125, 0.03. And that should give me tau A is equal, we have VQ, and V is 15 kilonewton, 10 by power 3, and Q came out to be QA, where are you? Right here, 0.72 times 10 by negative 3. Divided by, now you got to pay attention here. I was 0.218 times 10 by negative 3. And T, we're talking about the shear stress in the web. And I know we went over there to use this area here, but now we got to use the thickness of the web, which is 0.25. I mean 25 millimeter, which is 0.025. There, that's how we 1.99 megapascal. All right, so let's do the QB. Okay, let's do QB right here. QB is equal, no, we got that already. I mean, this thing's making a mess when you clean it. Tau B. And that's equal, again, 15 times 10 by power 3. And QB was 0.598. And divide by the moment, same thing down here, 0.218 times 10 by power negative 3 and times 0.025. I got that already, came out to 165 megapascal. So that's how you do it. Again, you look at this shape or the other shape, doesn't matter. First, find the neutral axis. Second, find your moment inertia. Third, find your Q. The tricky part of it is to find these distances. What's my Y prime? What's my D? And the rest of them is really plug in. Have a great week.